So far, we learned array, we learned linked list, right? And we learned the stack, we learned the queue, and we learned tree. Okay, so if you look at the diagram we having, right, at the beginning, right? Okay, we learned the linear data structure, almost done, right? And now we come to the non-linear data structure. We learned the tree, we learned the graph. We have learned tree, and today we're gonna cover the graph. Okay, we can cover the graph. Okay, so what is graph? Graph is also very important data structure in the programming world. Okay, so in your math, you learn the graph. Okay. Hold on, I'll come to this one, right? Okay. A graph is a non-linear, okay, this is another type of non-linear, right? A non-linear data structure consists of nodes and edges. Okay, nodes and edges, right? Nodes and nodes, right? And edge means the line, okay, or the path connect each node. Okay, so in the below diagram, or not diagram, graph, right? In the below graph, we can see a set of nodes, or in the math we call that vertex, right? In the set of the vertex, okay, we use V stands for the vertex. It is a set, right? It is a set of data. It contains 0, 1, 2, 3, 4. 5 nodes, okay? 5 vertices, that's the same thing, okay? 5 vertices. And we also have a set of edges, okay? Which is E, right? Equals to a set of edges, right? Each edges, we have 2 vertices. 0, 1, right? 0, 1 is this line. We have 1, 2, 2, 3, 3, 4, 0, 4, 1, 4, 1, 3. 1, 2, 3, 4, 5, 6, 7. We have totally 7 vertices or edges, right? We have 5 vertices and 7 edges. Okay, so this can stand for a graph. This can stand for a graph. And if we take a look at these 3 different graphs, okay, the first one, right? The first one, how many? Let me run execute. Okay, so this one, by looking at this graph, how many vertices do we have? Julian? How many vertices do we have in this graph?
6.
6. 1, 2, 3, 4, 5, 6. How many edges do we have? How many edges? Okay, let's start from 1, right? 1, 2, right?
6.
1, 2. Okay, 1, 2, 1, 5, 2, 5, 2, 4, 2, 3. Hold on one second. Yeah, I think I have to restart the Zoom, right? There's less than 1 minute. But here is 1, 2, 2, 5, 2, 4, 2, 3, 3, 4, 4, 5, 3, 6, 5, 6. Okay. So here, right, we just said that the 6 vertex, right, and 10 edges. Okay, it's very straightforward, right? It's very straightforward. Okay, let's take a look at the second graph, right? Again, the value, right, is number or letter doesn't matter. Okay, it's just the value of the node is different, right? It's like we can have different value, different type of value, right, in a node of the linked list or tree even, right? Victor, how many vertices do we have in this graph?
5.
5 or 6? Huh, Victor?
5.
It's 6,
Wait,
right?
wait.
Yeah.
10.
No, you look at I look at my screen. I'm asking how many vertices do we have here in this graph, the second graph? Huh?
I'm not sure. Oh, on the second graph there will be 6.
Yeah, on the second graph, right? 6 nodes, 6 points here, right? A, B, C, D, E, F. How many edges do we have? Okay.
1.
How many?
1.
Edge. Edge means line. The line connects each node, right? 1 AB, AC, BC, AD, BE, EE, EF, right? So there are 7. There are 7 H's here. Okay? So that's called a graph, right? You're gonna see the graph is more generic than the tree, right? Because tree, right? It had a child node, so there's the edge between the parent node and child node, right? But when we talk about graph, right? Graph means, okay, this really like one node can have multiple child nodes, right? As well as one node can have multiple parent node. And sometimes there's no relationship like parent and child. Why? Because, for example, like a D and an A, right? We cannot tell which one is parent, which one is child. Okay, we can only know they are connected. Okay, they are connected. And the A is connected to B, C, D, right? 3 different vertices. So they have edge, right? They're connected. And at the same time, D is connected to A, E, F, right? So that's graph. Okay, look at the last one. Okay, Jeffrey, you there? How many vertices do we have here in the
I'm here.
graph?
What do you say? How many vertices we have in the graph?
In the third graph.
In the third graph? 9.
How many?
9.
9. The third one.
Yeah, 9.
Count it again. Where did you get 9?
Wait, what are vertexes?
The node, right? The
Oh, 8?
Yeah, the 8. The 8 vertex, right? 5, 7, 3, 11, 8, 2, 9, 10. Right? How many edges? 5 and 11. There's 1, 11, 2, 1, 2, 3, 4, 5, 6, 7, 8. So the 8 widgets, right? 8 widgets. Okay, so you have to understand when we talk about graph, okay, you need vertex, right? How many points or how many nodes do we have in this graph? Second, we need edges. We need to know which 2 nodes are connected. Okay, so with that information, you can decide how the graph, right, look like. Okay, so now next one, you may notice, right, when we're talking about the previous one, hey, the first one, the second one, I just have a line connect to nodes, right? There's no direction, there's no arrow. But when we go to the third one, they connect, but they have a direction, right? Look, for example, like 5 to 11. It's 5.11. Any different? Yes, it's different. Okay. So from the definition perspective, if one edge without direction, we call that undirected graph. Okay, so which means there's no point or direction. It has to be from A to B or has to be to A. No, they just connect. You can go to A to B, or you can also go from like B to A. But if in the directed graph means it has direction, right? A, right? It can only be from A to B. B can only to C, cannot go to D because it has direction. Okay, so no, it's different. In the undirected graph, they're connected, so you can travel from one node to another node, or vice versa. Right? From B to A, from A to B, both are possible. But in a directed graph, all the travels has to be follow the direction. A to B, B to C, right? C cannot go to B, right? C cannot go to B. Who can go to B? D, right? D can go to B. A can go to B. Okay, very important. Another advanced definition of the graph is called a complete graph. So basically, you know, which means what? Which means every node, they are connected with rest of the node. Okay, every node is connected to rest of the node. So that is very, you know, edge case. Okay, we don't have to, you know, worry about that. Okay, so after talking about the direct, indirect, right? Let me go to next slide. This one. This is also another very common type of the graph. What do you see? Louis, what do you see from this graph? Louis? Hello, Louis, you there? I cannot hear you. Okay, Victor, what do you see from this graph? Victor?
I'm not sure.
Look at this graph, right? Do you see the difference from the previous graph we just looked at? Huh? Julian, what's the difference?
Huh?
No, my question is look at this graph. What's the difference from the previous graph we looked at? Right, this is the previous graph. What's the difference?
It's in a different shape.
No. You found for each age there's a number. Right? Age 0, 1. Do we have a number 3 here? Right? From 1 to 2, we have number 1 here. 4. So these are numbers called weight. It's a weight of the age. Right? It's a weight of the age. So the whole graph is called a weighted graph. Okay? So how to understand that? Right, weighted graph. Let's take a look at this use case, right? This example in our daily life. Okay, so the node here or the vertex here is very familiar, right? So they are cities. There are cities in the US. Okay, and then you can see cities are connected to another city, right? Like Austin, Dallas, right? There's two cities in Texas state. They connect each other, right? And then you find what? You find that we have a weight on each edge, 200 from Austin to Dallas. From Dallas to Austin is also 200. But if you go to from the Austin to Houston, it's 160. What is that? Right? So this weighted graph data structure can be used to describe like a map and the distance between each item in the map. Right? This 200, which means what? It can be stand for 200 miles, right? Or like 200 minutes, right? I don't know what's the unit here, but it means something, right? For the age. Okay, so if I understand this 200 miles, which means what? Which means if I drive from Austin to Dallas, these two cities, I need to drive 200 miles, right? And from Dallas to Austin, same, right? It's 200. Okay. If I drive from Austin to Houston, it's 160. Okay, 160. So the age, the weight on the age means how the age is here, right? And from Chicago to Dallas, right? Or from Dallas to Chicago, it's what? 900. Okay, 900 miles. Right? So this, we call that map, right? It's actually a weighted graph. Okay? So we have vertex, we have edge, and on each edge we have a weight. Okay? Also, we're using the graph in the social network, right? People have the social network. I have lots of friends that follow me or connect with me in the social media. Okay? But if I want to know, like, hey, if I wanted to know someone, he is currently not in my friend list, right? But he maybe can be linked through my another friend, right? What does it mean? Okay, suppose I'm here, I'm this guy, right? In the Facebook, I wanted to connect or know this girl, right? She is not the direct friend of me. How can I reach her? Okay, so then I just go check, hey, all the people I know, this guy, yellow, green, and this orange guy, right? These are three people I know because we are connected. Okay, oh, I know through the yellow and the green one, they are connected to this girl, right? So this is a graph. I know if I want to know her, I have to go through this friend or this friend. Okay, so that is a graph use case in the social network. So sometimes in some social network, right, it's showing your friend a social graph or diagram. It's showing you, hey, if you want to know someone, right, how many friends you have to go through. Okay, that's it. They're using graph. Okay, they're using graph. Next one. This graph use case is called division graph. Okay, that is also graph, right? Because you see the different nodes in the graph, and it can have different edges connect with each other. Okay, connect with each other, right? If I want to come here to here, right, I have to go through the different nodes. Okay, so that is another use case of the graph. Okay, so we are talking about some basic concept of the graph, right? And I can tell you the graph, the data structure is commonly used in most of the scenario in our daily life, right? As I said, right, in your social media, they're using the graph data structure to storing the connection, right, between the different peoples, right? If I want to know who someone, how can I know? Go through who? I can connect to the one I want to know, right? And how many level of the people have to go through, right? That's using graph. Okay, and write the map also, right? Nowadays, if you go to outside, you're using GPS, right? You're using GPS. You open the map on your phone, right? And we know there are lots of different road, right, or the highway you can drive. Okay, so for example, if I wanted to drive from Flushing to Manhattan, how many different way we have? A lot of, right? 3 or 4 different drive path, right? Then which one will be the best one? Okay, which one will be the best one? It depends on what? It depends on current traffic, right? Because most of the case, right, you want to arrive to a destination as fast as possible. Okay, so have you think about how the software know which one is the fastest? Okay, which one is the fastest? So they have to, if they wanted to know the time, which means they have to know the distance. Okay, so in the graphic, for example, like this, right? In the graphic, I have to know the distance firstly, right? Where the distance coming from the graphic. Hey, from Dallas, I want to go from Dallas to Houston, right? How can I go? You can go from Dallas to Austin first, and then from Austin to Houston. That's one way. Or you can go to where? Go to Denver, right? Denver, go to Atlantic. Atlantic, go to Houston. That is also possible, right? They're connected, which means you can drive and finally arrive to Houston. But the question is which path you're going to select it. Of course, which one is shorter. Okay? The distance has to be shorter firstly. And what's the second? Speed. Why do we have to consider about the speed in GPS? Because you care about the time at the end, right? So time equals to what? Distance divided by speed. If the distance no, so the speed, the faster, right? The time is less. So I have to do the calculation, right? The distance, how can I calculate? Oh, we know from the Dallas to if I go through Dallas, Austin, and Houston, the whole line distance is what? How many? Julian. Dallas, Austin, Houston, right? What's the distance, total distance? Julian?
Sorry, I was in the bathroom.
Okay, I'm asking you, do you look at my screen? This
Yeah.
diagram, I'm asking from Dallas, go to Austin. From Austin, go to Houston. How long, how much distance it is?
I didn't understand that.
Okay, Aston, do you understand what I'm talking about?
Yeah.
Okay, this diagram is called a weighted diagram. Why we call it the weighted? Because every age has a number, right? This number can stand for different meaning. But in this case, right, this number probably stands for distance. Oh, we know from Dallas to Austin is 200 miles. From Austin to Houston is 160 miles. Okay, you cannot just measure the line because the diagram can be a different layout, different shape. The line doesn't stand for. right? You cannot say, hey, this line is smaller than this line or shorter than this line, so which means this is distance shorter. No, you cannot do that, okay? Because it cannot tell you exactly, you know, how it is, right? But if you look at the number, if there's a number at the weight of the age, it's clearly tell you, hey, from Dallas to Austin is 200 miles. From Austin to Houston is 160 miles, right? So totally, if I go from Dallas, Austin, Houston, it's 360 miles. You know the distance, okay? Is that the only way? Is that the only path you can drive from Dallas to Houston? Definitely not. Right? Definitely not. Definitely it's not. Right? But here, I can drive from Dallas to Denver first. And then I drive from Denver to what? Atlantic. Right? Atlanta. Right? Dallas, Denver, Atlanta, and Houston. Yeah. Right? You can reach the Houston at the end, right? But what about distance? 780 plus, right? 1400 plus 800, right? It's almost 3,000 distance. Okay? Dallas, Austin, Houston, 360. Dallas, Denver, Atlanta, Houston is about 3,000 distance, 3,000 miles distance. So which one are you going to pick? Okay, which one are you going to pick? You're going to go through Austin or go through Denver, Atlanta? Again, right? In a realistic like case, right? Like, okay, you calculate from Flushing to Manhattan. There could be like 4 or 5 different paths. Okay? You want to go to arrive as soon as possible, and you need time. I have to know what the time. Okay? Time equals to what? Distance divided by speed. Okay, we know the distance now. We still need we still need to know the speed. Okay? Even maybe, hey, you know, from Dallas, Austin, and Houston, the distance is smaller. But sometimes, maybe because the traffic is super terrible, or the speed is super slow, right? If we go this way, then the whole time will be increased, right? The time will be very big. But if Dallas, Denver, Atlanta, Houston, right? I just give you an example, right? Even though they have 3,000 distance, but if the speed is super good, no traffic jams, road is good conditions, speed is fast, it may, you know, take less time than the Austin way. You get my point? So the GPS is working in our phone or our car, right? They do the calculation. Oh, they know what's the final or arriving time, right? For each way, right? And it's gonna just select the buy for you, right? Because you always make a setting that okay, take a here's the time, right, to this destination. Okay, so that is some like graphic stuff behind it. Okay, graphic stuff behind it. Okay, are we clear about that? Any more questions? Okay, so if not, let's quickly take a look at how we create a graph, right, in the Python, right? But before that, we're gonna talking about, right, dictionary again. Do you guys still remember dictionary? Right? So if I create a dictionary, so dictionary is we have learned, right, last time. We have learned the list, tuple, set, and dictionary. Dictionary has key and value. Okay? Has key and value. If I give you the key, you can get the value, right? So for example, let me add Okay, let me create a Python file for the graph. Okay, Python. Sorry, it's a little bit slow, but tried. Okay, choosing Python, create. Okay, here, let's talking about dictionary first, right? Okay, dictionary. So in Python, right, suppose I said create dictionary, my dictionary equals to, it's using curly brackets, okay, right, for dictionary. And very important, it need the key, okay? It need the key and the value, right? It need the key and value. So what type of key I can put, right? The key, it has, like in this case, like key and value. So now the key is, suppose I said, hey, I'm using a string as a key, okay? The name, right? I put name. Another string as a value, okay? That's the first key and value, right? Age. So the value can be different type, okay? And gender. Right? So I create a dictionary object, okay, which is consists of 3 pair of key and value. How can I use that? Right? As a print my dictionary, right? I'm using a script practice as name. What I'm doing here, I'm using the key to fetch the value. Okay, so I know I have a key as name, age, gender, right? So now if I run this, it's basically it's gonna get the value of the given key. Okay, so you can use that as a profile of the person, right? What's his name? What's his age? What's his gender, right? So if I change it to age, it will print out the value of the age key. Okay, how we change that, right? If you want to change that, same thing. My dictionary, like name, make it be different, right? I change that. I print a name. There I just print out the new value because I have changed the value of the key. That's called dictionary. Okay, this is also very important to the structure, right? In the Python or in most of the programming world. Okay, so now let's go back here for the diagram. How we create the diagram, right? So let me print out this one. Okay, we can see here, we are using a dictionary, right, for the graphic. because we already know graph, right? You need to know a list of the vertices, right? Like here, A, B, C, D, E, they're the vertices. And then for each vertex, for each point, I'm putting whatever the connected, right? Connected vertex to him. What does it mean? When I say A, for the key A, or the node A, the value will be B and C because they are the list of other vertex connected to point A. Okay, so if that's the case, I come here. Okay, so I said I'm gonna create okay, let me see if I create a graph. Like this, okay, graph for this one. Okay, graph and first I'm putting what? All the vertex at the key. Okay, I'm doing like that. I have five vertex, right? Which means I need to put 5 key. Okay, so let me modify this one. B, C, D, E. Okay, so I'm using all the 5 vertex at the key. And then for the value of the key, I'm putting what other vertex connect to it. A, B, C. Okay. Oh, we know A. For the vertex A, these are the other vertex connect to it. B and C. Right? What will B? B, right? We have A and a D. Okay? We have A and D. Okay? Then what about C? C, we have A and a D. Right? What about D? We have B, C, E. What about E? D. Okay? Is that clear? Victor, are you following?
Yes.
Okay. So very clear, right? So now if I print out graph, let's see what do we get. Oh, it's basically print out the whole dictionary object, right? Key value, key value, key value. Okay. So next one, we said I'm gonna create a graph class. And this graph class, right, the init function will take a dictionary as the input value, right? Input value. Okay, so what we're gonna do is, let me change the graph to graph data. Okay, so now I'm gonna create graph class. And in the graph class, we have init function, right? We have self and we have graph. Okay. And then we said this. Okay, here we're gonna do a validation. We have to say if the graph is not none. Okay. If the parsing graph data is not none, or I should put data, right? Or just data. Data, okay. If the parsing data is not none, what I'm doing is self dot graph, right? Dictionary. I give a variable name called a graph dictionary, right? You can also understand it's a data equals data. Okay, so the name of the variable doesn't matter. You have to know, okay, for a graph class, we are using a dictionary. We are using dictionary to contain all the information, right? To contain all the information. So if the data is not, okay, let me change that. If the data is none, okay, if it's none, so what we do, okay, we just create a blank dictionary. Nothing. There's no vertex, there's no edges, it's blank dictionary. Okay? And else, right? If it's not none, then we're gonna make graphic dictionary equals to the parting data. Okay? Equal to parting data. So next one, okay? We're trying to what? Create a function called get vertex. Okay, so namely, I want to get all the vertex of the graph. Okay, how can we get the vertex of the graph? Well, we know all the vertex are used as the key in the dictionary, right? So I just need to get the key of the dictionary, then that's the vertex of the graph. So what we do, F get vertex. Okay, again, it's a function inside the class, so put self. We just need to return, right? Self dot g right? Because what? I have a property called a G dictionary. So you need self dot G dictionary dot keys. Okay, that's very important. Dot keys. It's returning. Okay, it's returning all the keys of the dictionary. Okay, so now if I'm trying to create, okay, create the graph. G equals to graph. G equals to graph. Okay, I need to pass in data. Where the data coming from? That's the data. Right? That's the data. So the graph data, parsing the data, okay. And it's gonna do checking. If the data is none, obviously graph data is not none, right? So it come here. It set the data to the G dictionary. So which means what? The graphic is initialized with this set of data. And when I call print G dot get vertex function, right? I'm able to get order vertex, right? This is a function. So I add a parenthesis, right? If I run this, I have dictionary keys A, B, C, D, E, right? And of course, right? If you wanted to convert the dictionary keys to a list, you can just add a list, right? To wrap it. Now, if you run this, you're gonna see A, B, C, D, E, right? That's the 5 vertex in the graph. I'm muted for myself. Anyway, so what did I say is, so far we have created the graph class, which takes a dictionary as the data, right? And then we also create a function called getVertex to returning all the vertex inside the graph. Okay, which is what? Which is a key of the dictionary. Now, next step is we're gonna create a find age here, the find age functions. Okay, let's first take a look at that, right? Find age function, we're gonna returning the distinct list of ages, right? We all know the vertex, and we know who connects the vertex. So we just need to return the set of the two, every ages, right? So if we look at the code, first create an empty list, age name, right? And then what we do is we checking, right, every vertex in the dictionary, okay? And then we looping every connected vertex, right, inside the value of each vertex, okay? And we check, hey, if this age is not in the age, because what happened is, if I go back to my code, right, look at this one. What happened is AB is age, but BA is a duplicate one. Okay, it's a duplicate one. So we will not count it twice. We only handle it once. Okay, that's the reason why here we need an if condition set. Hey, yeah, this AB or BA is already in the age set or list. If not, then we append, right, this age into our result. And at the end, we return the whole list of ages. Okay, now let's take a look at that. Okay, what we do? We're gonna do, okay, I'm gonna change the function by myself, right? I said get ages, okay, so that's where it'll be more obvious. Get ages function, okay, so I'm gonna create an empty list, right? We said ages, ADGE, okay, and at the end, right, of the function, I need what? I need to return the ages, right? This is the purpose of the function. Okay, so the problem is how we can get the ages, right? We already have this dictionary. We know these are the list of vertex, right? And the value of each key is the connected vertex, right? So what we do is for every vertex was a V, okay? For every V in the self.gdic, right? That is the variable which is holding the data, right? Inside of the graph class. Okay. And first looping the key. And then what? For next V. Okay, let me make it V be bigger, okay? So we know, not next, we said connected. For each connected vertical, in where? I have a nested loop here, right? This loop will go to gdic V. Do you guys understand this? Right? I have first looping every key in the dictionary. And then I need a looping, right, the value of every key. Okay, the value of key. So the V here stands for what? A, B, C, D, E. And then for connect the V stands for B, C, A, D, B, C, E, and D. Okay, so now imagine I'm first looping A. V equals to A. Then this, right, the way how we fetch the value for the key, will stand for B and C. Okay, and then looping B and C, I'm gonna checking, hey, if AB, right, how we write that? If AB, if V connect the V, okay, not in edges. Okay, then we said what? Edges, right? Append V connected V. Okay. Yeah, that's it. So what I'm doing here, I'm looping the key, and then I'm also looping every item right in the value, and I'm checking, hey, is AB in the edge, right? If not, I append it to the edge, right? Okay. But when I go to B, right, I'm looping B, I'm looping N and D. When I'm checking AB, okay, AB, so AB, BA, they're the same thing. I will not count the edge twice. Okay, so I'm checking if it's not in the edges, then I add that, right? If it's already in the edge, I just ignore that, right? Ignore it, we'll go to the next item. Okay, so that's the way how we get the edge, right? Let me try to print out, right, what it will look like. G dot get edges. Okay, and I'll print out. That's it, right? But then the problem is it print out BA again. So which means this is not a good, it's counting the value, right? It's counting the value. What happens if I change it to this? I run this. Now this is correct. Okay, if you look at this. So this will ignore the order, right? Sometimes A, B, B, A in different districts, they think it's different value, right? So if we change this, okay, I think this is set. If I'm not correct, the set will, we don't have the order in the set, right? Okay, so in the set we don't have order. So A, B, B, A, they're the same thing. That's the reason why you have this condition, right? Okay, and it's print out AB, right? AC, BD, DC, and ED. Clear? So that's the 5 edges we have in this graph. Okay, so what's next? Next, we're going to talking about how we add a new vertex to the graph. Okay, so now let me do that. Def, add a vertex. Okay, and I have self and value, right? The new value. Okay, so for this case, because it's a new vertex added, okay, first I'm going to check, right? If, because if the new value, right, if the new value not in the self dot direct, right? I'm checking, hey, the value in or not. If it's already in there, you don't have to even add it, right? But if it's not in, then self dot G dictionary, we just need to add the new value or new vertex, right? And initialize as empty. Okay, look at here. Oh, I have A, B, C, D, E, right? If I want to add A, I'm checking, hey, if A is already in the dictionary. If it is, right, I do nothing. But if it's not, suppose I add F, DEF, right? So it's gonna add F, right? After you add that, what does it look like? Right, we'll look at this, right? We print out, right? So here I have this function, quite simple, right? So what happened here? If I said, hey, G dot add a vertex, passing a new vertex called F. Okay. Now if I print what? Print G dot G dictionary. Okay, I print on the property or print on data directory. If I run this, what do you see? Hey, I see the F vertex already added, but there's no connected vertex to him. Okay, now the last function I want to implement is called add age, right? I have the feature to add a vertex and add age self dot age. Okay, so basically age, right? We need to include two vertices, right? Two nodes, A to B, B to A. Okay, so when we say age, right, we're gonna say, let me see. So, well, let's look at this function together, right? So what we're doing here, we first convert A to a set. Okay, and then we create a tuple, right? Vertical 1 and vertical 2. And then we checking if the vertical 1 is in the self.g dictionary. If it is, right, I just need to append the vertical 2 to the value of the vertical 1. If it is not, okay, so which means I just added the key and the value, right, at the same time. Okay, so let's implement that. Here, what I first do is age equal to set age, right? While I'm doing that, I converted the age, converted the age parsing value become the set, right? Set is not allowed duplicate. Okay, set is not allowed duplicate, and then v1, v2, I just make it simplify, right? I converted the tuple. Okay, tuple had the order, right? Okay, now I have a tuple. Then we check if the v1 is in the self.g dictionary. Hey, is the v1 an existing key what in the dictionary, right? If it is, then I just need to update dictionary v1. Okay, which means there is already a listed value existing for that vertical, right? Vertex. So I'm append the v2. That's that. What am I doing here? Hey, if I wanted to add E and F, I'm checking if the E is already an existing vertex. If it is, I just need to append what? The F to the value of the E, right? So that is logic we're doing here. But if, okay, if the V1 is not in the dictionary, so which means it's not existing vertex. So what we do is else, then we do self.g G dictionary V1 equals to V2, right? You just create a new list for the V1 key. That's it. So that's a function to add age, right? So now let's take a look at that, right? What happened here is I have added the age, we have added the vertex F. Okay, I've added the vertex F. So we're gonna say G dot add age. Okay. Okay, we want parsing because it needs two value, right? V1, V2, right? Okay, like we have E and F. I'm adding an age for the vertex E and F. Okay, so now if I print out all the age, right? Let's see if we have the H and the E and F existing, right? Okay, I call this function. Okay, do you see here? I have E and F, right? So I added the vertex F, and also I added H, connect E and F. Okay, so if I doing here, step by step, right? When I added the vertex F, what it's doing is I create a F key and put a empty list at the value. Okay, and then you said, hey, add H, E, and F, right? It's gonna find, hey, do I have E and F here, right? If I already have, for the E, I'm gonna add F, right? And for the F, I'm gonna have E. Okay, so it's creating the H between the two vertices, right? So that's it. So far we create a graph function. We take the dictionary at the value, right, and get a vertex, return all the distinct vertex. Get edges, return all distinct edges. We have the function to add a new vertex and then add new edges. Okay, so that is the whole thing for the basic information about how to using or construct a graph data structure in Python. Okay, keep in mind the graph, right? It's more generic, okay? Unlimited size, because every vertex can connect to multiple rest of the vertex, right? So it can expand very big, very big, very big. Right? Imagine a map, right? It can have hundreds of the cities in the map, and then each city and the row connect with each other. And we also learn the weighted graph, right? Weighted graph, which we have a number of weights on each edge. It can stand for the distance or stand for the priority. I mean, it depends on the different use case of the weighted graph. Okay. Okay, so I think that's all. We have finished the basic introduction of the graph data structure. And do we have any more questions? Or are you guys following what I'm just explaining and showing you guys? Aston, any question?
No.
Okay. Victor, are you following?
Yeah.
Okay. Okay, so I think we already run out of the time, right? So again, right? So that is the last class of the whole period, and we covered almost all the basic data structures, and we have completed the quiz, right? We don't have assignment for the last class, okay? But I hope if you have time, right? Just have. I'm gonna post all the slides I'm prepared for the class, right? From the first class to the last one. All right, that's all cover all the data structure we learned. Okay, So I'll also upload the video of the last class. Okay, so you can just anytime you can review. And so that's about this period. And we're gonna take a rest for several weeks, and it's probably start our next period. The next period, I'm gonna get in deeper, right? Talking about different algorithms. Okay, so based on the understanding of the structure, we're gonna talk about algorithm, right? We said the whole program is all about the extraction algorithm. Okay, algorithm means hey, different question, how we can use different algorithms to solve the problem. Okay, like sorting, how we sorting a list, right? And how we make a search, right? And we also can discuss which the different and the way and how the performance of the different way when we solving the problems. So this is all very advanced stuff. Okay, so I think that's it. So if no more question, thank you everyone and enjoy the coming holiday seasons. Okay, thank you so much. Thank you. Bye bye. Have a good night.